What is the relationship between intelligent systems and machine learning? As it is obvious, intelligent systems need the intelligence. As the intelligence is being possessed by or exhibited by the machines, it is known as artificial intelligence or machine intelligence. This intelligence can be gained. The intelligence can be gained means it can be generated and it can be improved using machine learning techniques. Machine learning may in turn have several other techniques such as classification and clustering to facilitate the learning. Why this learning is important or how it is different from the traditional programming? There are lots of differences. In the traditional way, for each and every behavior that is required by the computer, you will be writing an instruction. You have to write. You will write each and every instruction. For example, if you want to determine pass or fail depending upon marks of a student, then you will write code for taking the input and deciding whether the mark is a passing score or not. You will write decision making code and then we will tell the computer how to present the output. That is your program. When this program is complete, you will execute this program and supply some sample data. By processing this data, the program will generate the output. However, in the machine learning, there are two phases. The first phase is known as training phase. During the training phase, you will directly supply some data. Along with this data, you will also supply expected outputs for each of this data. Data and expected output will enable this intelligent system to write its own program. This program is called as model. So the first phase, training phase, is intended in generating the model. And in the next phase, which is known as testing phase, you will just supply some more data and now the intelligent system will use the existing model and it will generate the output. You can imagine the machine learning can dramatically reduce the effort required by the programmer. For example, if you want to autonomously drive, if you expect an intelligent system to drive a autonomous car, how much code you may need to write if you are writing the program? It is almost impossible. However, if you teach the computer or teach the system how to learn by its merits, learn by its mistakes, if the machine is learning by itself, your tough job is getting easier. So it will reduce lots of efforts. But there is a small extra. In the traditional atmosphere, you just had to have the computer science knowledge and the desired domain subject knowledge. But however, if you want to use the machine learning tools effectively, it is very good if you can have some more mathematical and statistical knowledge. That will be very helpful for you to dig deeper. Now coming back to machine learning, there are several types in machine learning. The major varieties are known as supervised learning and unsupervised learning. In the supervised learning, human or we will supply some information to the learning system. So these informations can be called as class labels. In the unsupervised learning, we will be just supplying some input and the system is generating some groups in the among the input. It will find some relationships. Where these learnings will be helpful, use cases. Supervised learnings are very helpful in many areas, such as image classification, which you may have observed in Facebook. When you upload new image, Facebook will help you to tag the image, recognize faces, so on. And the another variety, regression, is helpful in predicting risk assessment, how much risk is likely, so on. And unsupervised learning is also applicable in many areas. One such application is business data analytic, where you group together certain sales data and improve marketing. Reinforcement learning, another variety. Sometimes it is related with supervised learning, is very helpful in gaming, robot navigation and many other sectors. What is this reinforcement? For instance, in a shooting game, if the system makes a proper hit, it might get a positive score. If it is a racing game, if the car never makes a hit, it may get a positive score. If it makes a hit, it may get a negative score. So in the robot navigation, drone navigation, so on. Anyway, this reinforcement learning is a very interesting area. Now we will move on to a little more depth of supervised learning. You may recall supervised learning involves two phases, training phase and the testing phase. In the training phase, we will be supplying lots of input data. In this case, lots of images, different images of grapes. And along with this input, we will also supply label information called annotation. What are these images? They are described in the annotations. Using this input data and annotation, the system is going to form the model. This model is generated and then the training phase is assumed to be over. And in the next phase, testing phase, some more images of grapes will be supplied, and now the system will use the existing built model to predict what is this image. In this case, for the image of a grape, the system will recognize it is grapes. It will label the image as grapes. In the case of unsupervised learning, the system is fed with lots of data. The system will try to establish some relationship. It will find some, or it will extract some relationships, hidden relationships. For example, these two fruits are having the same color, these are looking similar, so on. And finally, the system will generate certain categories of output. These are called as clusters. This is a cluster of apples, this is a cluster of orange, so on. Let's see one example for supervised learning classification problem. Let's imagine these are the images fed into a system. The system is learned its model already, and now it has to label whether these images belong to a male or female. Now there are two classes, male and female. This is a binary classification problem. Now the system has to check each and every image and it should mark whether it is male or female. For instance, after this classification, this might be probably a potential result. On the other hand, if the same images are fed into clustering, you can expect some different outputs. If the computer is going to establish if it can recognize the color of shirt or black pixel color densities, then these images can be grouped together, and these images could be grouped together as a different cluster. In a different scenario, if the learning algorithm is focusing on the color of the hair, let's say color of the hair, probably then these are the possible outputs. These are having one color and these two guys are having black color hair. And one more possible output, the type of hair, if the system can detect that. These are having short hair, these are having longer hair. This is forming a entirely different cluster, because instead of hair he is having a hat. Okay, so we have seen a bit about the learning and the intelligent systems. What's next? Obviously, one thing you need to do if you want to dig more, get into the roots. Learn fundamentals in depth. You will get lots of online resources for free to get into the depth. Probably if we meet once again, we'll try out some samples directly. Nothing is going to stop you from trying out some samples and trying out some free tools available, such as Anaconda package. Try out these samples. If we meet again soon, we will discuss about this. Thank you. Have happy learning.